All right, let's keep on with our discussion of slope. Remember, slope could be described as the rise over the run, which is the vertical change, which is the change in our dependent variable, divided by the horizontal change, which is the change in our independent variable. All right, so let's look at that formula in relationship to a line. So a line is a situation where there's a constant rate of change. There's no blip in it. This would be an example of a line that doesn't have a constant rate of change, right? Or this doesn't have a constant rate of change. There's some curving, it's changing, and all of a sudden it's getting much higher, and this is going down and going up. Those are not constant rate of change situations, so slope would be difficult. Wouldn't apply to these types of situations. But for this, that's a line, and we can talk about slope with a constant rate of change. So rise over run, we want to look at how is it changing vertically with respect to how is it changing horizontally. It's important to look at these nice clean intersections. Right here, the line is crossing at a nice clean intersection. Up here it is as well. So one thing we can do when we're given a graph of a line is we can just look at, okay, if I start at one point, what does it take for me to get vertically down to the next point? In this situation, I am going down. From here to here, that's 1, 2, 3. That's down, so that is -3. My rise is actually a drop, so that's a negative sign, and I'm divided by my run. So for me, now I'm here, and now I go over 1 here, my change in x is a +1. The slope of this line is actually -3 over 1. You could actually just say that the slope is -3. So I can do that by just counting it out. I can also look at some ordered pairs. So I have an ordered pair right here, and that ordered pair is 1, 3. So I have the ordered pair 1, 3, and I have another ordered pair. I have the ordered pair 2, 0. I have the other ordered pair 2, 0. So there are some ordered pairs that are given to me that came off of this line, and I could look at that and say, well, the slope is the change in my y values divided by the change in my x values. Okay, so I'm going to label this. I'm going to say that this is point 1 and this is point 2. It really doesn't matter. You can switch it and call this point 2 and this point 1. Regardless, this is one point on the line, this is another one. So if this is point 1, this is y1, x1 and y1. This is y2, x2, and y2. Sorry about that. So these are the x values to point 2. X and y values, those are these guys. And these are the x and y values for point 1. So that's this thing. So let's use that formula. My change in my y is my 0 minus 3, y2 minus y1. My change in my x is this minus this, my 2 minus 1, and I get -3 over 1. It's the same answer that I got up here. Slope is -3.